Hi everybody, and welcome to the next video looking at spectroscopic data in chemistry. What I want to go through today is a very brief introduction into the different functional groups that you need to be able to recognize. You see, spectroscopy is all about identifying the structure of an organic molecule from 3 different spectra. Okay, so before you can identify that sort of compound, you actually need to be able to know what sort of functional groups you might be looking for. Now, these are the same functional groups that we're going to look at in Level 3 Organic Chemistry, but of course we haven't actually covered Level 3 Organic Chemistry yet. Now, you don't have to be able to name these different compounds, though it is useful to be able to recognise them. And if you can name them, then great, but if you can't, don't stress about that. There may be issue or examples where you have more than one functional group within the same molecule, which is something that's actually more complex than you'll come across in the Level 3 Organic External. Again, you don't need to name them, but you do need to be able to recognise them. So without any further ado, I want to introduce the different types of functional groups that you might be coming across. First off, we have a recap of the functional groups that you dealt with in Level 2. So we had alkanes and alkenes and alkynes. So alkanes, carbon-hydrogen single bonds, carbon-carbon single bonds, only that plus bonds to hydrogen, so these are saturated organic molecules. There is nothing interesting or exciting about them. Sorry, but that's the truth. When we're naming them, we use our straightforward names of how many carbons in the chain, ended in ane, with any branches at the start of it. Alkenes are slightly more interesting in that we have a carbon-carbon double bond somewhere in the chain. We could also have potentially 2 or even 3 double bonds within the chain. Such things certainly exist naturally. Alkenes can also have other atoms attached to the carbon-carbon chain. So you could have a chlorine attached to the double bond or a nitrogen attached to the double bond or something else. However, in most cases, if there's some other atom attached, then that functional group will take priority over the alkene functional group. If the alkene functional group is the only one you've got of interest, then the name will end in ene, that is E-N-E. Alkynes are less common because they're so highly reactive. They have a carbon-carbon triple bond within the molecule, and their name ends in ine, that is Y-N-E. So those are all ones that you dealt with last year and even the year before in Year 11. Also from last year, we have haloalkanes and alcohols. Haloalkanes have a halogen attached to a carbon chain. So a halogen is fluorine, chlorine, bromine, or iodine, or astatine, but since that's radioactive, you don't tend to come across it very often. And the names are named for the parent alkane chain, so however many carbons in that longest carbon chain, with the halogen identified at the start of the name. So for example, 2-chloropropane or 3-fluoroheptane or whatever it happens to be. Alcohols are similar to haloalkanes in many respects, but instead of a halogen, they have a hydroxyl group attached to them. The hydroxyl group is an OH. They are named similar to alkanes, but the name ending is changed to OL. So ethanol, propanol, butanol, etc. You will also need a number in there if you're going to use the name to identify where on the carbon chain that functional group is located. But I'll talk more about that when we get to organic chemistry, because naming of alcohols and other such functional groups is really more important in organic chem. And the other 2 functional groups that you dealt with last year in Year 12 are carboxylic acids and amines. Now, carboxylic acids have a carbonyl group that is a C double bonded to an O and a hydroxyl group on the same carbon, which is at the end of our carbon chain. Has to be at the end of the chain because you've got 3 bonds associated with that functional group, so there's only 1 bond left to go out to the rest of the chain. The carboxylic acid is named as something or other oic acid. So, for example, ethanoic acid, propanoic acid, heptanoic acid, whatever it happens to be. Our amines are bases, and they have a nitrogen atom associated with them. Now, although this diagram shows an NH2 group, it doesn't have to be an NH2 group. It could be a nitrogen attached to 1 hydrogen and a second carbon atom. It could be a nitrogen attached to no hydrogens and in fact attached to 3 different carbon chains. However, all of those are named as something amine, or sometimes they're named as something amino, something alkane. Naming of amines, particularly secondary and tertiary amines, which are ones where you've got 2 or 3 carbon chains connected to the nitrogen, are outside the scope of what I want to get into in this topic. However, I just want you to be aware of the fact that nitrogens aren't necessarily attached to 2 hydrogens on the end of a chain. They could be attached to other things as well, other carbon chains. In all of these diagrams, the letter R means, well, you can just kind of think of it as the rest of the molecule, if you like. It is simply any length of carbon chain from 1 carbon through to 77 million carbons, if you want to think of it that way. Sorry, I know it's not 77 million, but you know, sometimes I get sidetracked by my daughter. Okay, so these are the first two of the new functional groups that you're going to deal with: aldehydes and ketones. Aldehydes and ketones are closely related. They both have a carbonyl group, which is a C double bonded to an O. The only difference between the 2 functional groups is that for the aldehyde, the carbonyl group is on the last carbon of the chain, so it's on the end of the chain. Whereas in the ketone, the carbonyl group is in the middle of the chain. That means you cannot have a ketone that has any less than 3 carbons because it has to be at the end of the chain. In terms of naming, aldehydes are named with a name ending of Al, Al, whereas ketones are named with a name ending of -one. So a 2-carbon or a 3-carbon aldehyde would be propanal. A 3-carbon ketone would be propanone. Okay, moving right along, we're nearly at the end of these. The last 3 functional groups that we have to deal with this year are esters, amines, and acyl halides. All 3 of these functional groups again have carbonyl groups in them. And I'm actually going to start at the end with the acyl halides, or particularly acyl chlorides, because you're only going to see ones with chlorines on them. Now, acyl chlorides are very similar to aldehydes, where we have a carbonyl group on the end of the chain. The only difference is that instead of having a hydrogen at the end, if you go back and have a look at the aldehyde for a second, you'll see you've got the carbonyl group, and then the carbon of that carbonyl group is attached to a hydrogen. In our acyl chloride, we take that carbonyl group, and instead of having it bonded to a hydrogen, it's attached to a chlorine. So that is our acyl halide, and we name it as something or other oil chloride for a chloride, which is the only ones you're going to deal with this year. Moving to the left, we have our amides, and amides are quite similar to amines. They're kind of like a cross between a carboxylic acid and an amine in some respects. So we have our carbonyl group, which is attached to a nitrogen, which could be attached to 0 or 1 or 2 hydrogens. If it's attached to no hydrogens, then there are 2 carbon chains coming off the nitrogen. We could have 1 carbon chain and 1 hydrogen, or simply 2 hydrogens. So that makes the difference between a tertiary, a secondary, and a primary amide. Again, you don't need to name those primary, secondary, and tertiary, well, the secondary and tertiary amides, you do need to name the primary ones. But at this point, it's more important to be able to recognise when they're present. The final functional group is the ester, and that is the one that probably confuses more people than any other functional group. It is, you can think of it as a carboxylic acid. Okay, so we've got a carbonyl group attached to an oxygen as well, single bonded. But instead of that being an OH group, it is an oxygen connected to another carbon chain. So we have two distinct carbon chains on an ester. If we don't have two carbon chains on an ester, then it's not an ester. So we have one carbon chain connected to the carbon with the double bond O on it, and a second carbon chain connected to the carbon with a single bond O, or rather connected to the oxygen, which is connected to the carbonyl carbon. The names of those are quite complicated. What I want from you at the moment is simply for you to be able to recognise when those functional groups are present. And we will talk about those in considerably more detail as we go through. Okay, so those are all the functional groups that you need to be able to recognise. We will talk about these in more detail as we get to the different spectra. I will see you in the next video. Thank you so much for listening.